Hi everyone. So let us have a look at the solutions in a little bit more detail. So this is the question you were given and you needed to calculate the mean, median, and basically all of these values. So you should be able to calculate all of these using your calculator. And there are videos. So if you're using a Casio, here's a video for how to find those, some of those, like the mean and variance and standard deviation. There are built-in functions for that. And also for some of you, I know I've seen using a sharp. So watch the video and make sure that you're able to use your calculator. So you'll see that what I did as well with now is I put a note here that says the brand A data has also been uploaded to you for you in Excel in this document here. So if I go back to ClickUp and I scroll down now, this is where the exercises are here, and this is the file that I'm talking about. So if you download this file, then you end up with a spreadsheet that looks something like this. Okay. And this would have been maybe the quickest way to do the questions. So I want to show you how to do it this way, but you should be able to do it for a calculator. Maybe in your calculator, you can do it maybe for a smaller data set because I know it's quite a lot. They're like 40 values, so it will definitely save you time to use my Excel spreadsheet instead. Okay, so if you look back now at the question, the question is telling you here that you have this comparative box plot with battery lives, and then in the middle here, you have hundreds and tenths. So this is 0 hundredths and 6 tenths. So in other words, this 6 represents 60. And then if you go, let's say, to this value here, then you'd have 69. If you come on the other side, that's just 60, which is 60, because these are your ones. As another example here, you have 1 hundredths, so that's 100. You have 3 tenths, so that's 130. And then when you take the units, this would be 133. And if you go to the other branch, this would be 139. Okay, so now I'll ask you to calculate the mean, and you should add the values into your calculator as your data, and then there's a function that will automatically calculate the mean. So make sure you're able to do that. You can test it out on a smaller data set where you know the mean, just to save you time. If you decided to do it in Excel, you would have now calculate the mean as follows. So you say equal sign, and then you will type in average, and then you will drag. Okay, cool. And then in here, you just want to close your brackets and press enter. And then this is how you will get the mean. The next part of the question asks you for the median. Remember, the median is just the middle value. So we have 40 observations. So if we go down to 20, I'm going to draw a horizontal line there using this drop down here, thick bottom line. So this is where our median is, okay? So the median, therefore, is 88. Okay. And then if we go back to our question sheet, you want the 10% trim mean. So for the 10% trim mean, you chop off 10% from either end, 10% of the observations from, so the top 10% and the bottom. So 10% of 40 is 4. So that means we're going to drop these first 4 observations and then calculate the mean using everything else but without the last 4 observations. So you're going to stop here. So in Excel, if you want this trimmed mean, I'll just put here 10% trimmed mean. Okay, just pull that over. Then you'll say equals mean again, open bracket, and then you start from your 5th observation, and then you will stop, oops, a little bit too far, 4 observations from the end, which should be 36. So you see I excluded 4% here and 4%. I close the bracket, so you see that's how it looks when I click on enter. it gives me the final answer of, oh, there's been a mistake, A5 to 107. Okay, there's some error. Invalid name error. Oh, sorry. Look, I typed in mean. It's supposed to be average. That's why I got the error. So enter. So don't make that mistake. And then the other thing I asked you for then is the standard deviation. I'm just going to write standard deviation. And note well, we want the sample standard deviation because this is a sample. Okay. It says clearly here, this is samples of 2 brands. So you don't have all the possible battery lives for each and every single battery. So it's a sample. So what you're going to do is do equals and then std, and then you'll see you get these 2 options. stdev, that's your standard deviation based on the entire population. And then the one with the S, if you double click, this is the one based on a sample. So you use the one with the S. And then here you want the standard deviation of all the data. Now a trick to highlight everything more easily without having to drag is you put your cursor, just click on the first value, and on your keyboard press on Control and Shift at the same time, hold them, and then press down on your directional keypad, and it goes all the way to the bottom. And then if you release them, then you can close the bracket and click on enter, and then it'll calculate it for you. So note when you do that kind of a thing, like if you have values like this, and then if you have a gap, and then you carry on your numbers, for example, if I do Control, Shift, and drag down, it stops where the numbers end. So just watch out if you have a gap, because then you'll have to press again, down, down, to get everything you want. So that will give you your standard deviation. And then for your fourth spread, you need your upper fourth and your lower fourth, and then your fourth spread. I'm going to call it FS. So for your upper fourth, remember you're taking this half here and dividing it in half. So that would be here at 10. I'm going to do a horizontal bar. And then you can see here that the average of the two is just 79. Okay, so if you take the average, or you can sum them, so I can open brackets and say this plus this one and divide it by 2, you just get 79. So maybe I should have just done it in my formula over here. So this is for my upper fourth. I'm pasting my formula back in the cell. So that's 79. And then the other one, so remember you have observations, is also 20. When you split them in half, that means you're going to stop here at 30. So I'm going to do a horizontal bar. So you can even check here how many observations to make sure you didn't make a mistake. And here it says the count is 10. So I did hopefully correctly split into 10, 10. See, 10, 10. But then it's the average of these two values. That's where I'm going to get my lower fourth. So I said equal, and then I'm going to take, you can do it the same way we did it, where you open bracket and you add the two, or you can do the average. So let me do it the same way. So 99 plus 101 divided by 2. So you can see my formula, and if I press enter, it gives me 100. And then my fourth spread is equal to the, oh, I swapped them around. So I'll fix that just now. So this is my lower fourth and then upper fourth. So to get my fourth spread, you must take your upper fourth and subtract your lower fourth. So if I do that in formulas, that's equal to upper fourth minus lower fourth, which gives me 21. Okay, so that's how you get those answers there. Okay, so we quickly just want to open my detailed memo so you can see now those are the other answers that we got there are the answers that you should have gotten. Okay, so if we just compare our answers quickly, you will see that's actually how I calculated them. It was just a lot easier and faster. Hopefully you saw to do it this way. Okay. Now, the next part of the question is asking you now for consider the brand A data. So let me make this a little bit bigger. So it says comment on the skewness based on your answer in A1 and A2 and give a reason. So when you look at A1 and A2, you see here that your median is smaller than your mean. So remember your mean, since it uses all the values to calculate it, it means it's affected by all the extreme values. So if you have an outlier that's very large or very small, then the mean is going to be pulled in that direction. The median is not affected by it. So for example, here where we have 89.2, there's a large value, this 139. It is pulling the distribution, or rather all the values, your mean, to the right because it's so big, and the median sort of gets left behind. And when you have a mean larger than your median, you say that it's skewed to the right. If it was the other way, where you had lots of really small values, the mean would have been affected by that. The value would have been pulled to the left, and your median would have ended up being bigger. And when you have a mean that is smaller than your median, then we'll say that the data is skewed to the left, or negative skewed. So just remember that, and I've explained why that's the case. For B part 2, comment on the skewness based on the given stem and leaf plot. Is the skewness the same as what you observed in B1? So here I just wanted you to see that, okay, when you looked at the median and the mean, does it agree with what you see in the graph? And the answer is yes, and I'm going to show you that just now. So this is the brand A data, and then in order to see the skewness pattern, I turned it over on its side here in this graph. So here it's looking like it's skewed to the left, yet we just said it's skewed to the right. And the reason for that is because when you turn it over just like that, the large values end up on the left and the small values on the right. But remember, when we do our number line, we usually put the negative values on the left and the positive on the right. So when I reflect them like in a mirror, then I get to put the large values on the right and the small ones on the left. And you can see the skewness, like you have this tail, like the end of your data is sort of jutting out towards the right side. So therefore your data is right skewed or positive skewed. So we conclude that we are observing the same thing. So I wanted you just watch out for that. When you're looking on the left side, it can be a bit reversed. Now, in part C, I wanted you to be able to identify mild outliers and extreme outliers. So mild ones are the ones that are not very far from the rest of the data, and then extreme ones are significantly further from the rest of the data. So the formula that you're going to use to calculate your cutoff values is you're going to take whatever value you have for your upper fourth and lower fourth, and then you're going to either subtract or add 3 times your fourth spread. So I'm going to show you what that looks like graphically because I think it's a bit easier. So here, this is like a typical, let's focus on the bottom part first. So wherever your median is, it's not necessarily in the middle. You'll have your lower fourth and your upper fourth, and those are the values we calculated in part 1. And then when you calculate now, notice here on the left, it's lower fourth minus 3. This is the one we were looking at just now for the extreme outlier. This lower fourth minus 3 of the 3 times your fourth spread. And then for your other cutoff value, which is closer to your data, it's minus 1.5. So you're not going out as far. And then here you're going to calculate upper fourth and then add 1.5, and then upper fourth plus 3 times your fourth spread on this side here. So you're going to calculate these values, and then you're going to see if any of your data falls in this region here. If it falls in between these two values, it's a mild outlier on this side and that side. And if it falls anywhere, anything here much bigger than this upper value, so then this is an extreme outlier, and that's an extreme outlier as well. So in your calculation, so remember, let's look at, let's say, this first cutoff value here, and we'll look at then that one. So upper fourth plus 1.5 fourth spread is 100 times 1.5 times 21, which is our fourth spread, which is 131.5. So 131.5 is over here. And then for the more extreme cutoff value, it's 3 times instead of 1.5, which gives you 163. So that means this value is 131.5. It's what I have here. And 163 is here. And I said for mild outliers, any value in that region is regarded as a mild outlier, anything out there. So then you're going to go to your data and see, do you have anything bigger than 131.5? And if we go back, we do. We have 139 here. Okay. So this is definitely past this 131.5 boundary, but 139 is smaller than 163. Therefore, it is a mild outlier. You'll do the same on this side, so you can double check the calculations here. So this is like your 16 is over here, 47.5 is over here, and you'll see there are no values in this area. So the only outlier we have is at 139, which is a mild outlier. That's what I wanted you to identify. And now when it comes to drawing your box plot, this is how it would look. So remember, this bottom end of your box plot always corresponds to your lower fourth. The upper part always corresponds to your upper fourth. And then when you put out your tails, I think before you put out, the whiskers, rather plot your outliers first. So if you have any mild outliers, you use a shaded circle. If you have any extreme outliers, you use an open circle. So if it's on this side as well, same pattern. And then once you have put in your outliers, then your whiskers go up to the value, the next value that is not an outlier. Okay, so that's why I said put your outliers first. So we know, for example, that 139 was a mild outlier. So we don't draw the whisker to 139. We will draw the whisker up to 129 instead, because that's the next value below 139 that is not an outlier. So let's look at the next part of the question now, that where you had to now draw it. So remember that we found 79, 88, 100. So this is your median, this middle value, your lower fourth, upper fourth. And then we had no outliers, so you draw this whisker all the way to the smallest value, which is 60. And then on the other end, remember we said 139 is an outlier. So we draw a shaded circle because it's a mild outlier. And then we draw this whisker at the maximum value that is not an outlier, which is 129. Okay, so this is what your box plot should have looked like. And then comment on the features. I think basically here when you look at it, you can see skewness. So to determine skewness, look at the box. Yeah, look at the box and not the whiskers, because those can really spread out. So the majority of your data is here, and you can see that the majority of your data, most of it is to the right of the median and a little bit less. So this indicates skewness to the right. If you had a box where, let's say this is where your median is here. Oh, okay, let me hold it here. Then you'd have more space on the left, and then you'd say it's skewed to the left. So if you ignored this line, if this was bigger, you'd say it's skewed to the left or negatively skewed. So always look here in order to determine whether you have skewness or not. If the block was divided perfectly in half, then you would say, okay, it's symmetric, pretty much. Okay, so that explains this comment here, skewed to the right. For question 2, you're supposed to do comparative box plots for calorie content of 2 types of hot dogs. And now you needed to give a reason for which measure of location and spread you're going to use. And we've already started talking about these things. So hopefully it makes sense. You'll see in your textbook, they talk about sensitivity to outliers, because you can see here you have some mild outliers, and here there's even an extreme one on the poultry hot dog. And when you look at these 2 box plots, you can see most of your data is actually quite high versus this one here. So we can immediately see that the beef has a higher calorie content than the poultry most of the time, although there are a few outliers, but the majority of the time you're going to find that you have more calories in the beef. And then if you look at your skewness, we can immediately see here we have skewness to the right. So remember, look here, the big block is towards the bigger values, and then the small block is towards your smaller values. So it's either you can say skewed to the right or positively skewed. And this one, the bigger box is on the smaller values. So it's negatively skewed or skewed to the left. But anyway, in terms of now measures of location, the typical ones we're going to work with are the median, trimmed mean, and your mean, and even your mode. But the most important ones we're going to work with are the first 3: median, trimmed mean, and mean. So when you want a suitable, so now I want you to be able to identify when is the best case to use what. So whenever you have data with outliers, you want to use the median. Remember, the median takes the middle value only, so it's not affected by outliers, whereas the mean, if you just take the mean, it uses every single value. And if you look at the beef here, there's this extremely small value. The mean will be dragged a little bit towards this really small value because it uses all the values. So the median is totally insensitive to outliers because it ignores everything. And then the trimmed mean is a little bit better, okay? So whichever answer you gave me would have been fine. Hey, I don't mind. If you had given me the median and just said, okay, it's insensitive to outliers, you would have gotten the marks. Or if you said trimmed mean, because it's not as sensitive to outliers as the mean. So remember, the mean is the one that's most sensitive because it uses all the data. But at the same time, the trim mean is not as insensitive as the median. So the median is on the other extreme. It just ignores them totally. So the trim mean doesn't discard as much data as the median. Remember, median just looks at the middle and then it's like, I'm done. The mean looks at everything, and then the trimmed mean, it drops some values, and then you can still use the majority of them. So that's why we say that. When we look at variation, we're talking about the spread of the data. So that's where you have things such as the range, your interquartile range or fourth spread, and your standard deviation and variance. So in the presence of outliers now, you don't want to use the range. So remember, the range is your maximum minus your minimum, because automatically you are just using those outliers. So we never want to use the range, like almost never, because it discards all the information. So you either want to use either the fourth spread or interquartile range. So remember, the fourth spread or interquartile range, I'm going to go back to the summary. It's actually only this part. This fourth spread is only the lower fourth, upper fourth minus the lower fourth. And lower fourth and upper fourth, they're very similar to your upper quartile and lower quartile. So you can also talk about your interquartile range. So it only focuses on this data here, and it ignores those extreme values on the left and the right. So the fourth spread is less sensitive to outliers. So in other words, it is less affected by outliers. So you would want to use interquartile range or fourth spread in the presence of outliers, rather than range, which actually only uses those extreme values. And you don't want to use standard deviation or variance either, because they use all the data, including those outliers. So it's similar to the mean that also uses all the data. And then now when you compare the distributions here, so you say location. So if we look at our median, so our median are these values here. You can really see the median for your beef is bigger than the poultry. So the B is for beef, P is for poultry. And I mentioned earlier, beef is positively skewed, poultry is negatively skewed. So we covered that already. And then in terms of variability, in terms of the Ford spread, if we look at the size, remember Ford spread is the difference from here to here only, right? And they're about the same size. So we commented here and said that they're more or less the same, the spread of the data. Okay, so let's now have a look at question 3. So for question 3, you are given these totals, and then there are values you need to remove and you need to add back. I think maybe let me write this one a little bit more on the tablet so I can expand, because sometimes I know this summation throws some people off. So I'm going to shift to my tablet and write a few things for you. Okay, so in this question, they're telling us, all right, we have these incorrect observations and these are the correct ones that we need to include. So if we start off with this sigma notation, what does this mean? This is basically saying it's shorthand for I equal to 1 up until n. Here it's up to 20. They took the sum of all the observations and then you have xi. So you will do x1 plus x2, and you'll keep on going until you reach x20. So you just repeat everything, whatever's here, you will repeat it, and then you just keep changing the value of I, starting from 1 and ending at 20. So that's how the summation works. So they're telling us here that now, okay, we need to calculate the mean. So remember the mean, the formula is x bar is equal to the sum of all of the x values divided by n, which is the number of values. So now if we have the sum of x and we know we've included 2 incorrect values, then what we want to do is subtract those 2 incorrect values. Oh, sorry, this is 20, right? So I'm wondering, how should I? Maybe x incorrect 1 minus x incorrect 2, and then we want to add back x correct 1 and x correct 2. Okay, so our x incorrect 1 is actually our 770, which we now remove, and then your 510, and then you add your 1000 to 2, and then your 280. So now if you want to calculate your sample mean, then whatever you get from that, which is this value actually, you should get 11,860. Okay, so okay, that's fine. You will take this value. So we know that all of these up to 120 sum to 11,860. And then if you subtract the values that they gave you and you re-add them, it actually turns out that they don't change, which is what they did there. So that's how you do the calculations to get the sum of the correct sum of x, and then you divide by n to get the sample mean. So 11860 divided by 20 gives you 593. And then for this notation with the x squared, it's going to be quite similar as well now. So when you have x squared, so they're putting it like this, right? Then what they mean here is that you still once again take that and you repeat it now, and you keep changing the I. So it's x1 squared, x2 squared, up to x20 squared. But then you want to remove, you know in here you've included all 20, including the wrong ones. So that 770 you want to now square it. So the incorrect values now also need to be squared and subtracted, and then you need to add the square of the correct values to get the correct value for your sum of x squared. So if you evaluate this, so in here, this is 8,438,200. That's this value here. And then you adjust it like that. Then the final value that you should get is this now, okay, which is slightly different to the original value. So then now if you want to calculate your standard deviation, now you need to use your formulas in the book. So on page 33, you'll have this first formula, but we don't usually use that one. We use the computational formula. So the computational formula is the one, it's on page 38. It'll be in your formula sheet as well. And this is what it looks like. So on page 38, you'll see something like SXX, and it's n divided by n minus 1. So SXX is just what I have in the numerator, and n minus 1 will be this at the bottom. So n is your sample size, which is just 20. And then SXX is taken by taking the sum of the xi squared, which we calculated over here again. And then this is the sum of the xi's, which is here. And then notice the big bracket is outside of the whole thing. So you square the final answer only. You don't square each value. Okay. So now if we substitute in there, this is the, if this is my formula here, that is my 8,663,660. It's coming from here. Sorry, it's a bit messy. And then we square that summation, which is coming from here. And then the 19, there's the 20, because remember there's an n inside here first. So that gives you a 20. And then you divide everything by 19, which is n minus 1, which is that part. But remember, they wanted the standard deviation. The standard deviation is just the square root of the variance. So this formula I gave you is for sample variance. So now you need to take the square root. And they just took the power of a half to get the square root. And then this will be your final answer. I hope you got that. And then now it says comment on how your answers compare with the original sample mean and standard deviation. And let's see, hopefully they're self-explanatory. So the sum of the two new claims is the same as those replaced. So we did notice that when we did the adjustment, this 11,860, this didn't change. Therefore, when we calculated the x bar, it didn't change. For the sample variance, this one increased as the two claims are further away from the mean as compared to the two claims in the first sample. So let's quickly maybe look at it in terms of a sketch. So if this was our data, and let's say it's starting from whatever this value is, I don't know what that value in particular is, but in the original summation we had 770 and 510. So maybe that was here. 510 and 770. So if we assume those are like, yeah, if we know that the spread is at least something like that. Yeah. I don't know if they tell you anything else. I don't think they tell you. Yeah, they don't tell you these are the largest values or anything. But you know for a fact that, okay, your spread is at least something like that. 710 like that. And then the moment you replace those values, now you're given 280. So let's say 280 is going to be somewhere here. But then you have that 1,000. The 1,000 is somewhere, let's say, here. Now, if you look at how spread out the data is, it's now wider because you've added a bigger value now. So that is what they mean, that you replaced the old values with bigger values. Therefore, you have you expect a larger standard deviation. Okay. Okay, they're comparing the distance to the mean. I forgot to incorporate that aspect, but you can see already logically. So this would have been, for example, maybe my mean or my mean. Okay, cool. All right. Oh, my mean is 593. So mean is actually in here. So you can see how close those values, the 5, 10, 720 are to the mean, and how the 1,000 is much further away. So anyway, if we look now at part 4, which is the bonus question, if you attempted it, this is basically what's going on. So what they're saying is maybe you have data like this. So you have x values where the values are, let's say, 2, 4, 1. If y is those x values, and then you add some constant, let's say the constant is the value 2, right? Then y is equal to 4, 6, 3. Yeah, added 2 correctly. Then what they're saying here is you need to show that if you calculate your y bar, you're actually going to find that it's the same as x bar plus 2 in my example. So if you shift all your data by a little bit, even your mean is going to shift by the same distance. That's what it means. So the way you're going to do it is whenever you have something like this, you always start on the left-hand side and then try to show that it's equal to what's on the right-hand side. So on the left-hand side, you have y bar, and you're going to start off by using the definition. Just always start with your definitions. And we know according to the definition of y bar, it's the sum of all the values of y divided by n, the number of observations that you have, right? And then from here, we were given, I don't know if you picked it up here, but basically what they're saying is for any yi equal to xi plus c, and then this is actually just rather a shorthand notation. Okay, so this whole line that I have here can be rewritten like this. So I could have said, suppose you have yi equal to xi plus c, where I is equal to 1 is to n. So it's a similar thing. So now if we look here, in place of yi, we are going to substitute this now notation that I have there, which is xi plus c. Now, this is where you need to now know your rules for summation. Okay. So just to give you an example, if you have the sum of, if it's I is equal to 1 to, okay, yeah, x1 xi plus c up to 3. I'm going to break it up, okay, right? So in other words, I'm saying you need to take everything inside the summation and then you repeat it as many times as you need to. So starting from I is equal to 1 up to I is equal to 3. So it's x1 plus c plus x2 plus c plus x3 plus c. And then you can actually rewrite this. So you have x1, x2 plus x3 plus c plus c plus c. So that's just rearranged. And if I put it back into the summation notation, then I have I is equal to 1 up to 3. That's xi. So that's this part here. And then for the c, you can do the same thing here. I is equal to 1 up to 3 for c. So that's where you get this part here. Okay, so whenever you have your summation, you remember you keep repeating what's in here and then you change the value of I. So obviously there's no I. So this, whenever you have that constant or value which has no I, it is just repeated from I is equal to 1 up to 3, but the I doesn't really feature. So this is where that line comes from. And then in the next step here, there's a rule. You can just memorize it, really. If you have the sum from I is equal to 1 up to 3 of any constant, then you can take that value. Let me make it n in general. You'll take n, it's equal to nc. So if you look at my example, there are 3 c's. So I can actually rewrite it. I is equal to 1 up to 3 xi plus 3c. So it's a direct application of that rule here. So that is how they end up in this step here. So you need to memorize this rule. You need to make sure you memorize that rule as well, that you can put a summation inside. When you have brackets like this, you are allowed to put your summation inside in front of each term. So memorize that one and then this one here too. That's important. So now now this n, remember it's also in there and in there. So now if we take the xi and divide by n, this is what you end up with. And then the other one where you have nc over n. So that part, you just end up with c because the n's cancel. But this is just the definition of x bar. So therefore, that completes the proof. X bar plus c is, we've shown here that y bar is equal to x bar plus c. Okay. And then for part B, now a little bit more complicated, but still not too difficult once you have the result from A. Now, same thing, left hand, show left hand is equal to right. So you start off with left hand and you must write the definition. So this is your definition from page 33 in the textbook. And then now we're going to do the same substitution. So here where you have yi, remember we said it's just this thing here, xi minus c. So that's what we have here. And then for the y bar, we've just shown that y bar is equal to x bar plus c. So here is my y bar. So remember this minus sign, watch out for it. So I put everything in brackets and I put x bar plus c from the previous result. Okay. And now when I expand these brackets, I will end up with xi minus x bar. And then you'll have a plus c minus c. So the c's cancel out and you're left with xi minus x bar only inside the squared term. And then you should notice that this is actually your definition for s squared x. So then that completes the proof here. Okay. All right. I'm noticing here this c squared, it shouldn't actually be there now that we've done the proof. I'm going to correct that. I apologize for that. So what this proof is actually telling us is now this part. So if this is your data here and it's from here to here. So this is x1 up to whatever your x value is, if xn. They're saying that if all of these values are shifted, let's say now you have x1 plus c by some constant, and then xn plus c. So to all of them, you've added c. Then what they're trying to demonstrate is that if you look at the spread of the data, so remember, standard deviation or variance measures your spread. If you look at your spread, it doesn't actually change because all you've done is you've moved all of the data by the exact same amount in a particular direction. So that's why you don't have that C there and the variance remains the same. That's what this whole result is telling you. So this is just to help you understand what do all these symbols mean in real life for you. Okay. So just to round off, the result that we were proving is actually this one here. We actually were able to show that this is true. And in this week's quiz, I want you to see if you can do this one, and then I'll discuss it in detail in Friday's session. Otherwise, that is the end. I hope this helped clear up things. This is on page 36, by the way. And feel free to post questions on the discussion board if you need a little bit of clarity. All right, enjoy the rest of your day. Bye.